You are provided with solution P, which is 0.625 molar hydrochloric acid. Hii inamaanisha kwamba solution P concentration yake ama molarity yake ni 0.625. So capital M huwa inasimamia molarity. Na molarity actually simply means the number of moles in 1 liter. So wakati wote unapoona umepewa 0 point something capital M, inamaanisha kwamba hizo ni moles ambazo ziko katika lita moja, 1 liter. Kwa hivyo simply this it means that 0.625 is the number of moles. It's the number of moles in 1000 centimeters cube. Hiyo ndiyo inamaanisha kwamba moles in 1 liter. Solution Q, sodium hydroxide solution. Solution R containing 49 grams in 1 liter of diabasic acid. So nataka kuzungumzia hili jina diabasic. A diabasic acid ni acid kama sulfuric acid, yani iko na 2 hydrogen. A monobasic iko na hydrogen moja. Tribasic iko na hydrogen 3. Sasa an example of a diabasic acid ni hii. Sulfuric acid iko na hydrogen 2. So this R is an acid which is an example of sulfuric acid. I'm not saying it is sulfuric acid, but I'm just using an example. Sasa nataka kuelezea hii. Inamaanisha wakati solution ilitengeneza solution R, 49 grams of the solid waliweka ndani ya maji, wakakoroga alafu wakatengeneza lita moja. So ndio maana inaitwa 49 grams in 1 liter. 49 grams was dissolved to form 1000 centimeters cube. A liter, remember 1000 centimeters cube inatoshana na 1 liter. So ukishaelewa hivyo basi kazi inakuwa rahisi. Procedure. Using a pipette, place 25 centimeters cube of solution Q. Lazima kwanza ushike solution Q ni nini? Solution Q ni sodium hydroxide. Solution B ni HCl. Sawa? Using a pipette, place 25 centimeters cube of solution Q into a 250 centimeters cube volumetric flask. Add distilled water as you shake and make to the mark. Label this solution S. Fill the puree with solution P. Pipette 25 centimeters cube of solution S into a clean conical flask. Add 2 to 3 drops of phenolphthalein indicator and then titrate with solution P from the puree. Then record. So, tuko na solution Q, which is sodium hydroxide. Tumeambiwa to pipette 25 of Q, tuiweke kwa 250 volumetric flask. Tukishaweka ndani tunaongeza maji mpaka inajaa. Ikifika ile mark inafika 250 centimeters cube. So tunatengeneza solution S. Lakini sasa unafaa kujua Q, ukumbuke ni sodium hydroxide. S yenye tumetengeneza bado ni sodium hydroxide. Tofauti ya S na Q ni concentration. Tofauti hapa ni concentration. Q is highly concentrated than S. Kwa sababu tumefanya dilution. Kitu tumefanya ni we have diluted. Hiyo ndio tumefanya. Kwa hivyo ni vizuri kuelewa kwamba na tumeambiwa tu pipette 25 solution S, lakini ukumbuke S ni sodium hydroxide. Sawa sawa. Kitu kingine nataka ujue kwamba tutaulizwa calculate the number of moles of the original 25 centimeters cube. Ili upate moles in the original, moles in 250 centimeters cube solution S itakuwa equal to the moles of 25 centimeters cube Q. Umepata hiyo? Number of moles in 250 solution S will be equal to the number of moles of 25 centimeters cube solution Q. Moles in 250S will be in moles in 250 centimeters cube solution S will be equal to the number of moles in 25 centimeters cube solution Q. Ukumbuke hiyo. Table nimefill. Kumbuka kufill table na decimal point moja ama mbili. Initial you can put 0.0. The decimal point you can use 1 or 2. So what to calculate the average? Average, you just add this 26.9 plus 27.1 plus 27.0 divided by 3. Itakupea 27.0 centimeters cube. So tuangalie hii swali. Calculate moles of P used to react with 25 centimeters cube of diluted solution S. Sasa tunataka calculate moles of P in 25 kwa sababu B we used fill the purate with solution P, and the average here P is 20 used to our average is 27. Remember this is solution P. So tunataka ku calculate the number of moles of P yenye react na 25 of S. Sawa? Lakini tuko na nini ya P? Tunarudi huku nyuma, you are provided with. Unakumbuka tulipewa concentration ya P. Tuliambiwa kwamba 0.625 is the number of moles in 1 L, which is 1000 centimeters cube. So tukijua hivyo, unakuja hapa chini, unasema hivi. Ikiwa 0.625 is the number, capital M inamaanisha simply means that 0.625 is the number of moles contained in 1000 centimeters cube solution B, of solution B. Sasa yenye tumetumia P hatujatumia 1000, tumetumia 27. So tunataka kujua 27 yenye tumetumia ikareact na S yenye iko diluted ni ngapi. So tunauliza hapa 27 centimeters cube solution B inaweza kuwa na moles ngapi kama 1000 iko na hii. Kwa hivyo sasa unapiga question yetu iko hapa, tunapiga hii times hii tukikuja hapa. That is 27 times 0.625 divided by 1000. Na hii inatupea 0.016875, na hizo ni moles za solution P. Sawa? Roman 3, calculate the number of moles of solution S in a 25 centimeters cube of the diluted solution. Sasa hapa tunaangalia uhusiano kati ya S na P. Kumbuka P ndio imereact na S. Sawa? S tunajua ni sodium hydroxide. P tunajua ni HCl. So it's a neutralization reaction ambayo inatengeneza sodium chloride. So let me write the equation here. S is sodium hydroxide plus P is HCl. So this one is a neutralization reaction which will form sodium chloride plus, sodium chloride plus, there's nothing here. This is, let me call it aqueous. Sodium chloride plus water. The ratio, as you can see, is 1:1. But we have the number of moles of P that reacted with this, which is 0.016875. This is the number of moles of P, HCl, which was 27 centimeters cube. But the ratio, the reaction ratio is 1:1, meaning that the number of moles ya HCl itakuwa equal na number of moles of sodium hydroxide in 25 yenye ilitumika. Therefore moles, okay, here you write that mole ratio is 1:1. So moles of S of 25 centimeters cube S equal to the same 0.016875. Right? Inakuwa rahisi hivyo. Sasa hapa tumepata moles of S in 25 tukitumia hii relationship. Kwa hivyo sasa tuna next one tunaulizwa calculate the number of moles of sodium hydroxide in 1000 centimeters cube of solution S. Sasa tunajua 25, 1000 tatushinda kweli? Haiwezi. So we say that 25 centimeters cube solution S iko na moles hizi 0.016875 moles. So tutauliza 1000 centimeters cube of S itakuwa how many moles? So ni 1000 times e divided by e. That is 25 times 0.016875. You divide by 25. This one is 1000, sorry. 1000 times this divided by 25. Na hii itakupa. So this one will give us this 0.675. Because it is in 1000, we call it capital M because it is molarity. Moles in 1000 is always called molarity. Now the next question, Roman B, is that using your results in A, Roman 2, determine the concentration of moles per liter of the original sodium hydroxide solution Q. Hapa ndio nilikuwa na kueleza hivi. Ukumbuke tulichukua 25 centimeters cube ya Q tukaweka kwa 250 centimeters cube volumetric flask. Tukaongeza maji ikafika 250 volume. Sawa? Kwa hivyo unafaa kujua kwamba moles, kwanza tuna calculate moles in 250 solution S. Tulitoa 25 centimeters cube original sodium hydroxide Q tukaweka kwa volumetric flask. Ikafika, tukaongeza maji ikafika 250 centimeters cube. Tukaita solution S. Kwa hivyo tukijua moles in 250 centimeters cube, tutajua automatically moles in 25 Q. I hope you umenielewa hivyo. Kwa hivyo sasa tuna calculate moles in 250. We have moles of S in 1000. We have moles of S in 25. So we can use that to calculate moles in 250. Tukipata moles in 250 solution S, tutapata moles of 25 solution Q. Kutoka hapa sasa tutapata moles in 1000 Q. Good. Haya, so tunasema hivi kwamba 25 centimeters cube solution S, right? Sodium hydroxide solution S ilikuwa na moles 0.016875. Hizo ndio moles zake. Sasa tutauliza 250 centimeters cube itakuwa na moles kiasi gani? Sawa? So hii ni 250 times 0.016875. We divide by 25. 25 once here, 10. So the number of moles in 250 itakuwa 0.16875 moles. These are the number of moles in 250 solution S. Sawa? Nimesema kwamba moles in 250 solution S will be exactly equal to the moles in 25 ile tulichota 25. Kwa sababu moles does not change. Right? Therefore, it means that 25 centimeters cube solution Q iko na moles ngapi? 0.16875 moles. Lakini question inauliza determine the concentration in moles per liter. Concentration in moles per liter, it is, we want number of moles in 1 liter. A liter is 1000 centimeters cube. So tutauliza 25 centimeters cube Q, the original, iko na hii moles. Je, 1000 centimeters cube of original itakuwa moles ngapi? Ni 1000 times 0.16875 and then we divide by 25. So hii itatupea 6.75 capital M. Capital M stands for molality, or you can say, you can write mole per liter. It's accepted. Part P, procedure 2, empty your puree completely of solution P and rinse it with some distilled water. Fill the puree now with solution R. Pipette 25 of solution S into a clean conical flask. Add 3 drops of phenolphthalein indicator and titrate with solution R. Record. I have recorded the table, and I have always emphasized that the table should have 1 decimal place or 2, and then make sure the arithmetic is correct and the table is full, is complete. So the average is 17.5 plus 17.5 plus 17.5 divided by 3, and the answer is 17.5 centimeters cube. Now calculate the number, determine the number of moles of sodium hydroxide in 25 centimeters cube solution S. We already have this one from our previous, so you just write that the moles of 25 centimeters cube S equal to 0.016. We had that from our previous 0.16875. Or if you have forgotten what you do, we know the concentration of S. You can also do it in this way. So from here we know that the concentration of S in 1,000 is this. So we will say 0.675 is in 1,000 centimeters cube. What about 25? So it will give us 0.016875. So we already have that answer. Determine the number of moles of R that reacted with 25 centimeters cube of solution S. So R, remember, is a diabasic acid. It is H2A, which is diabasic. And then we are S, remember, it is sodium hydroxide. So the reaction will take place. So this is an acid like sulfuric acid. Remember the reaction between sulfuric acid, the way you write it. So we are going to form sodium and then A. A, we'll put it 2 here because it is a diabasic, and then plus water. So we will balance the equation by putting 2 here. So now the diabasic acid and the sodium hydroxide will have a ratio of 2, mole ratio of 2 to 1. But we have the, this is, remember, it is 25 centimeters cube. We have the moles of this, which is 0.016875. Tunazo hizi moles is a sodium hydroxide. Na ratio ni hii. So hii question nimeandika aje. Ukiwa na a diabasic acid unachukua an example of sodium of sulfuric acid. Nikiandika equation hapa ya sulfuric acid, ni sulfuric acid tunajua inaandikwa hivi SO4 alafu plus sodium hydroxide. Si unajua kuandika, itakupea sodium sulfate. Kwa sababu ni diabasic, so the sulfate will put it to here. Kwa sababu sulfate iko na valence 2 plus water. Sawa? So tutabalance equation kwa kuweka 2 hapa. Umeona? So hii 2 ifai kwa sulfuric acid. So 2 inafaa kwa sodium ndio ziko mbili. Kwa hivyo this 2 is not supposed to be here, it's supposed to be here. Now the ratio here is 1 acid to 2 base. Right? Now it means that we have the number of moles of the base. Sulfuric, the acid now, the diabasic acid, we can get the number of moles using the relationship, which is the ratio 1 to 2. So we will say 2 equal to this. What about this? It means the number of moles of the acid is a half the number of moles of sodium hydroxide. Therefore, moles of R equal to 1/2 times this 0.016875. Now you tatupea 0.008437.5. So moles are E ni hiyo. 2 ilikuwa ifai kwa sodium. I hope umeona hiyo marekebisho. Na unajua nilikuwa nimekosea Na sasa ukiangalia hapa, hii imenisaidia sana kujua what I was supposed to do. Kama ni monobasic, ni kitu kama HCl, ni acid kama HCl, monobasic. Calculate the concentration of solution R in moles per liter. So concentration in moles per liter. A liter is 1000 centimeters cube. Kwa hivyo sasa hizi moles tuko nazo za R, hizi moles tuko nazo za R ni moles za volume gani? Remember the average volume of R. So 17.5 moles zake ni hizi. So tunaanza hapo, tunasema 17.5 centimeters cube. Moles zake ni 0.0A084,375 more. So tunauliza J 1000 centimeters cube itakuwa na moles kiasi gani? So ni 1000 times 0.084 0.284,375 you divide by 17.5. Na hii itatupea 0.4821 moles per liter or capital M. Moles per liter or capital M. So hiyo ndio concentration in moles per liter. Natumai umeipata vizuri. Find the relative formula mass of A. Remember our acid, the diabasic acid was H2A. So we want to know the relative formula mass of A. Utajuaje? Kwanza kitu tunataka tufai kujua naye hapa ni RFM. What is the RFM of this compound? Unapata aje? Unatumia hii triangle. Triangle inasema kwamba molality, concentration in moles per liter equal mass in grams per liter and then equal to RFM. RFM. So hii ni formula. Ikiwa nataka mass in grams per liter, nitasema ni molality times RFM. Saa hii nataka RFM. RFM is equal to mass in grams per liter divided by molality. Molality niko nayo ndio hii ya R. Sawa? Alafu you are provided with, kumbuka hapa, lazima ukumbuke hii. Tulikuwa tumepewa kwamba R ilitengenezwa kwa kudissolve 49 grams in 1 liter. Hiyo ndio inaitwa mass in grams per liter kwa hii formula. Mass in grams per liter. Kwa hivyo sasa RFM relative formula mass of this diabasic acid equal to mass in grams per liter using this formula, grams per liter divided by molality. The molality of this R is this. The mass in grams per liter we have 49. So we write now we have 49 divided by 0.4821. And this one will give us 101.6. 101.6. So this is the RFM of the diabasic acid. Lakini tunataka kucalculate A. So inamaanisha H2A inatupea the total of 101.6. I can leave out the decimal point or you can round off to 2. 102. Hydrogen umepewa 1. 1 hydrogen is 1. So 1 times 2 plus A itakupea 102. 2 plus A itakupea 102. Kwa hivyo A ni 102 minus 2. Kwa hivyo A ni 100. A ni nini? Ni 100. 100. Natumai umesaidika kwa hii tutorial. Nimeweka several links kwa hii video kwa description, ambazo hizo links zitakuelekeza kuangalia videos ambazo nilitengeneza awali za moles. Ni nyingi sana. Ukizifuatilia kwa ukizifuatilia moja kwa moja basi ninajua utapita practical. So tafadhali angalia hizo links moja kwa moja, ukiwa na wakati iangalie na utasaidika kwa practical chemistry. Don't forget to check the links in the description, because they will direct you to videos that I made early, which are very, very important in your chemistry life in high school. Thank you very much. The links in the description, because they will direct you to videos that I made early, which are very, very important in your chemistry life in high school. Thank you very much.